Hi, GEO 132. I hope you had an amazing spring break. Nobody came to Zoom today, so I just quietly worked on the lab. This lab looks really intense, and I promise you it isn't once you get the hang of it. Um, you do need to be careful and go slowly through the exploration and make sure that you understand it. But once you understand it, it's really just coloring things in and connecting the lines. So the way that it's explained in the lab, if you've never done anything like this, might seem really foreign, but it's not, trust me, it's really, once you get started, it's not going to be too bad. So I'm going to share my screen and we're going to going back and forth from the shared version to the not shared version so that hopefully this makes sense. So really what you're doing is you're drawing and correlating stratigraphic columns, which you should understand at this point is, at least with the what a stratigraphic column is it's a picture representation of the different kinds of rocks we see and their properties as we go down in the stratigraphic column. So you are going to need to print the stratigraphic column form. Don't skip over that step because everything else is going to be super confusing if you don't. I do recommend making 3 copies, maybe 4, and you are going to have colored pencils ready. I always am really, I know it's late in the semester, but I'm always really a big fan of these erasable ones by Crayola, just because it's really easy to make a mistake on a lab or a map. And yeah, you don't like, it's just easier than starting over from scratch or like coloring really hard the other colors. So like, definitely worth it to get the erasable ones by Crayola. They erase really well, like regular pencil does. So, it says use the descriptions in table 3 to 5 to draw your stratigraphic column. This seems really overwhelming. You're going to actually need 2 pieces of information. You're going to need these columns, but then you're also going to need this figure 7 down here. So this figure 7 here tells you what colors you need to use. It tells you how to actually show the grain size. And the easiest way to understand this is with an example. So I am going to stop sharing. I don't think I'm sharing anymore. I am sharing. Stop share. Okay, I'm going to stop share so I'm nice and big and show you the first 3 on just column A. So this is column A, and hopefully this makes your brain cells organized where you're like, oh, that is way simpler than I thought it was, because they're using a lot of technical language. That's one of the reasons I want you to go really, like, really read the exploration on this one, because the language can get, it sounds really technical, it can sound really scary, but really we're just coloring and making lines. We're showing that representation by color. Okay, so this is column A. It says in column, and I know it doesn't label it really well to the centimeter. So just guesstimate where, so I said 2 centimeters started here. So it says 2 centimeters depth on the stratigraphic column. It's shale. Now in figure 7 says shale is gray. We color it gray on this column, and that we can always rely on the fact that the grain size on shale is mud. So you can see that I made this about 2 centimeters down, and then I made basically, it's almost like a histogram. I made this line go all the way to mud, which is right here, which is what shale is made of. That's the grain size. And then I colored it gray like it shows in figure 7. For the next one is conglomerate. Conglomerate is pebble sized and it goes down to 7 centimeters. So I bring it all the way down. You see, I started at the 7 centimeter line. I drew across to pebble, and then I shaded that rectangle orange, which according to figure 7 is the color that we're using for conglomerates. And then down here, we can see that we have this big yellow square right here. This is sandstone. So the sandstone, according to the table, what's the table number on that? According to table 3 for stratigraphic column A, it goes all the way down to 19 centimeters. So I start my line at 19 centimeters, And sandstone is a medium grain sedimentary rock. So I go to the medium line and I have this big box, and then I color it yellow because that's the color coding we're using according to figure 7. So you can see once you actually take a look at what they're describing, it's really not super complicated. Now it tells you to transfer that to your lithostratigraphic cross section. This is your stratigraphic cross section, and I've started A over here. Notice I'm just putting the depths and the color coding on. That's a smudge from the capper, but I'm just putting the depths and the color coding. So once again, on top I have my shale in gray. The next one down is my conglomerate in orange. This is all based on figure 7. And then I have my sandstone. Ooh, there's a Raleigh trolley in the hallway. Sandstone in yellow. Now, I also did the first 3 layers for column B because in the next step, we're going to have to connect those layers together. So you can see that I'm not adding all that information about grain size or anything. I'm just giving the base identity of the rock, the lithology, okay? I'm not giving a description of what's called the facies. You'll learn more about the facies when you read the exploration, which is what this chart is all about. You have to put comments over here describing these layers. You're literally just putting lithology. You're just putting the type of rock here. So how do we connect these? This is just connect the tops. You connect the bottom of the shale to the shale. You connect the bottom of the conglomerate to the bottom of the conglomerate. You connect the bottom of the sandstone to the bottom of the sandstone. Now, when you get to column C, one of the layers is going to pinch off. It's going to get so tiny it doesn't exist anymore. And you just bring those lines together, okay? So let me show you how those lines will look connected. So you can see that even though the language we're using and the concepts we're learning about are pretty complex, like Walther's law, this is based on Walther's law, the actual lab itself isn't that difficult. It's really just coloring boxes. If you've ever made a histogram, you can totally do this. And I know most of you are science majors and have absolutely done a histogram. I do recommend pencil on this. It says at one point, it's like, go over it with black marker. No, I'm okay with pencil. I'm okay with doing this whole thing in pencil. Just make it dark enough that it shows up on, because you never know when you're going to need to erase the bugger. And this is definitely a lab where it's easy to make like a little mistake and then have to go back and erase. So you can see how I would connect these two columns together. And then these represent, well, we'll talk about what it represents. Then I would just take these quadrilaterals and I would color them the respective colors. So this one would be gray, this one would be orange, and this one would be yellow. Now let's talk about what this actually means from the geologic perspective. So what happens is that people take cores at different locations, and those cores are basically, they drill down the core. It's actually a really cool machine. It's like a series of teeth with gears in a circle, and it goes straight down into the rock. And then when it pulls up with like a tube of rock, not a hollow tube, but it's like this basically like this giant rock stick. I have some down in my lab. And so, but you're not doing that everywhere. You're doing that at specific locations, okay? So what we're doing in between these columns is we're trying to get a picture in our heads of what we can infer based on these different interpolate really, those of you who have taken some level of calculus or some statistics, we're really interpolating, okay? We're trying to imagine what's going on in between the columns we've chosen, okay? Now, like most of our labs from Science Interactive, there is an error in this lab. It says, flip this over and do the chronostratigraphy. Problem is, you flip this over and it's blank. So I wrote the publisher that the flip side of the lithostratigraphic column has no chronostratigraphic column, but that's okay. We don't need that. We're just going to add the chronostratigraphic information, the ash layers, straight onto this lithostratigraphic column. That's fine. That's totally okay. It's not even going to be confusing. It'll actually, hopefully, seeing the layers of rock connected to the ash layers will actually, I think it's better. Honestly, I think that it's better to do it that way because then you can really see which rock layers it's connected to. So, so that's this lab. There is a section on regressions, transgressions and regressions. And I know you've handled that a little bit inside your Cengage materials, but you haven't really in this lab. They don't, like, I went through the entire exploration. I did not see a real upfront explanation of transgressions and regressions. So you can just skip over those questions. Okay, that's okay. I don't feel like you're adequately prepared. It's something I would like to discuss, but it's not something that's actually integrated into this lab. And because it's not information integrated into this lab, I don't feel like you have enough information to complete this lab with just that element. Okay, but 98% of this lab is fine, and 98% of this lab is totally doable. It's really just coloring it in and then answering the questions about what you colored in. So don't worry about this transgression and regression thing. Just ignore that. Okay, the Cengage material covers it. I think it covers it more in depth. So you can definitely look at that and get it from there. But it's not in the lab, and I know some people are doing some stuff out of order. So don't feel obligated to actually put it on the stratigraphic column. Other than that, it's pretty straightforward. It's really not a bad lab. It looks scarier than it really is. I am very confident that you can do this. And you know who you can ask if you have questions about this lab. They got 2 thumbs and a PhD. It's this guy. So don't be afraid to email me or ask me any questions if you start getting lost. Because like I said, the language is really high level, but the actual doing of the lab is really 5th grader stuff. It's really just connecting lines and coloring it in. And you can totally do that. It's just using language that you learned during the exploration. And just as one more reminder, go through that exploration slowly. I know you can totally like buckshot on a barn door, click, 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 go through the exploration to get to the lab. You're going to want to slow down. You're going to want to read that stuff or you're going to feel real lost. And it's mostly really, it's just a vocab thing. You're learning a lot of vocabulary in that exploration. So I'm here to help you. I'm always happy to Zoom. I'm always happy to meet, even if it's at a weird time of day. Remember, Tuesday, Wednesday, Thursdays, I can definitely meet with you outside. Like I can meet with you online. And yeah. And online, I'm sorry, I can meet with you online during any of my office hours, but I can meet with you in the evening. I can meet with you in the evenings on those days. So if you work, don't worry about it. I got you. That's what this class is for. That's why it's online. It's obviously not ideal taught online, but it's for making it convenient for you. And I want to make it convenient and I want everybody to get a good grade because you should. I want to see like, I want to be drowning in A's. Okay. But you got to help me out and earn those A's. Okay. So peace out. Hope you had a great break. And as always, thank you for being my student.